This is problem number 5 from section 4.2. In this problem it says complete parts a through e for the function negative 4x squared plus 2x to the fourth. Identify the graph, identify the turning points, estimate the x-intercepts, estimate any local or absolute extrema. I'm going to use the TI-84 to graph this, so we're going to say y equals, and we're going to type in negative 4x squared plus 2x to the fourth. Hit enter, and then we got to change the window. Let's make sure the window will start with negative 10 to 10 for each of these, going up by ones. Remember, the YSCL stands for going up by ones on the Y scale, and same thing for X. We're going to hit the graph button, and let's see if we get the graph that we're looking for. Now, I know this is the graph that we're looking for because we have a degree 4 polynomial. And if we look at the number of turning points for a degree 4, we can have, it says a polynomial of degree n can have at most n minus 1 turning points. I'm going to turn that sideways so you can see that. A polynomial of degree n can have at most n minus 1 turning points. Well, we have degree 4 can have at most 4 minus 1, which is 3 turning points. You can see we have 1, 2, and 3 on that graph. So we know that this is showing the polynomial. So we don't have to change the window there. Now let's start to identify those turning points. So part B, I'm going to kind of label these out. C, D, we're going to be trying to find a min and a max for the local. And part E, we're going to do the same thing. We're going to try to find the min and the max for the absolute. Let's start by using the calc button, which is written right there. Second calc, and then we're going to look for some minimums first. And there's a minimum, I think, here, so we're going to go left bound, right bound. Guess it, please. It says the minimum is a negative 1, negative 2. So that's a turning point. So one of our turning points is negative 1, negative 2. One of our minimum values is negative 2 for our local. It also happens to be an absolute because it's one of the lowest points. Or it is the lowest point on the graph. There's another one that reaches that exact same spot, but that means that we have a local min, or an absolute min of negative 2. Let's go ahead and use that calc button again. Let's find a maximum this time. That's the middle. Looks to me like it's at 0. Let's see. Well, it's giving you like e to the negative 13, so it's basically 0. So we're going to say that that is 0, 0 for our turning point. And that means we have a local max of 0. And a absolute max, it's not absolute because these jet off into to positive infinity on either side of it. So it's there is no absolute max. Now we need to look at, and by the way, that does touch the x-axis there, so we're going to say that that is that's obviously an x-intercept, so that's one of our x-intercepts as well. So we're going to say x equals 0 for one of the x-intercepts. So we got a lot done with that maximum there. We're going to go to second calc, and we're going to go to minimum again. Left bound, right bound, guess it please. Tells us 1, negative 2 for a turning point. So 1, negative 2. And then that means that we have negative 2 already at a min, so I don't need to write it twice. We already have it as a minimum. And that's all we've got there. So let's find the x-intercepts in. So we're going to do second calc, and we're going to go to the 0 button. Find the x-intercepts. I know there's 1, in between these two spots. And it tells me that's negative 1.4. And then I'm assuming the other one's probably 1.4. We already said 0, but let's go ahead and try and guess it. So 0, left bound, right bound, guess it, and it is 1.4. So now we have all the x-intercepts as well. So we have looked at and identified all the information from this graph that's the important information.